When you have the two-slit experiment, you end up with both diffraction and interference. Recall that interference is when waves from different sources constructively and destructively interfere with each other to create a pattern. We could see that pattern here for interference. Now each slit also has diffraction going on as well. The waves at the top of the slit will have a different path length than the waves at the bottom, so they can interfere too. How can we reconcile these two ideas, interference and diffraction, with the two-slit experiment? The bigger dark spots here, 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 and here actually turn out to be effects of diffraction. Interference patterns are caused within those dark spots and give us this description. Now let's go back to the equations we saw before. I know it's a lot, but we can actually understand it. So for interference, which are these patterns, we saw that constructive interference occurs based on this, where lambda is the wavelength of this, coming from the source, L is just the distance, and little d is the distance between the slits. Similarly, we could classify the destructive interference by simply looking at n plus half instead of m. Diffraction describes the bigger dark spots that we see in the pattern. Here, it depends on big D, which is just the size of the individual slits themselves. So, changing the distance between the slits will only affect interference because that's little d. That means that if we make little d bigger, that means y will get smaller and we'll end up with very, very small distances between each of our dots. Now, on the other hand, we can change the size of the slits themselves, and that will affect the diffraction pattern. So if I make the slits really, really thin by increasing big D, we'll see that sine theta must get bigger. So we'll actually spread out where these patches will go.